Lecture 2, Voltage. Welcome back to Electric Circuit Theory 1. In this lesson, we will discuss voltage. By the end of the lesson, you should be able to both describe and quantify voltage. This lesson builds upon charge flow. Remember that charged particles exert a force on other charged particles. The charges that you see here, positive and negative, have electric field lines that point towards the negative charge, the way and away from the positive charge. So the force per unit charge is called electric field. And remember, the charges flow because their electric fields exert forces that push each other. So these electric fields that are pushing the charge will help us to define voltage. Now, what is voltage? When moving through an electronic field, a charge either gains energy or loses energy. Charges lose energy when they're moving in the same direction or electric field's line. The charges that you see here have an electric field line that points from top to bottom, and the charges are moving in the same direction. So they are losing energy. Charges gains energy when it's moving in the opposite direction of the electric field lines. So this charge would gain energy if they were moving from bottom to the top. Now, voltage is the energy that is either gained or lost per column of charge, and because it's the energy gained or lost per column of charge, we can use the definition to calculate voltage. So consider charging moving from A to B. Voltage is the change in energy per column of charge. So we can express it as the first derivative dW dq, or it can be expressed simply as energy joule over charge in coulombs. So voltage is simply energy over charge. We'll use a variable V and the units joules per coulomb or volts. Okay, let's have the quiz. First quiz says 4 coulombs of charge lost 20 joules of energy when moving from A to B. What is voltage EV, or the V E to V? And the second says 21 joules of energy are required to move 3 coulombs of charge from B to A. What is the voltage V to E? Pause the video for a moment and try the quizzes on your own, and then play, and we'll work through the quizzes together. So here we have 20 joules of energy, 4 coulombs of each. So our voltage is 5 volts. In this case, we have 21 joules energy and 3 coulombs of charge, or 7 volts. However, notice that the voltage or the charge is moving in this case from B to A, which is against the electric field line. So this voltage is negative. A negative voltage actually means that we gain energy. A positive voltage means that we have lost energy. So when the charge moved from A to B, it lost energy. We're moving the electric field lines and we get the positive 5 volts. Then we move from B to E, we gain energy going against the electric fuel lines, and we get a negative sign 7 volts. Another important fact to realize about voltage is that the measurements are always from the reference point. In other words, voltage measurements are relative, not the voltage itself, but the measurement. As an analogy, consider the mountain. In order to measure the height of point A, for instance on this mountain, we must define a reference point, because we could measure A from B, or we could measure E from C. Or we could even measure A from sea level. Now, A has an absolute height, but that height doesn't mean anything to us unless we actually define the reference point. And it's similar for voltage. In order to measure a voltage at point A in a circuit, we have to define a reference point. And this reference point only affects our measurement, not the actual direction of the electric field. That causes the voltage to drop or increase. So in this cartoon, you see that the electric field lines are actually pointing from A to B. We can take a voltage measurement measuring B as the plus end and E as the minus end. So we could measure E as the plus end and B as the minus end. In the case where we measure B as the plus end, then current going from B to E or voltage drop from B to E would be negative. A voltage drop from A to B would positive. But it depends on the way that we take our measurement. So let's see how that is applied when we look to the voltage drop around the circle. Now we consider the mountain above just once more. If we traveled one point from point E to B to C and then back to A, our height has not actually changed. Similarly, in a circuit, if we traveled from A to B, C, D, and then back to A, our voltage has not changed, and that's because the voltage add from one point to point. So let's look at the circuit and consider. If we go from C to B now, then we go to from C to B, we go from plus to minus, which means we have dropped. We've gone down 6 volts, going from minus to plus. Now, from B to A, we're going from minus to plus instead of plus to minus. We're going from minus to plus, so we're actually increased. We've gone up 4 volts. So we went down 6, but we only went back up 4. So at point that we've got a total of down 2 volts. Now we go from minus to plus, which means we're increasing. We go up 5 volts. When we travel from A to B, minus to plus is up 5 volts. Just like when we went minus to plus, where we went up 4 volts. So at this point, we've gone down 2, but we've gone up 3. So we have total of 3 volts. Now we go to from minus to plus, which means we're increasing. We go up 5 volts when we travel from A to B. Minus to plus is up 5 volts. Just like when we went minus to plus, where we went up 4 volts. So at this point, we gone down 2, but we've gone up 3. So we have a total of up the 3 volts from D to C. We're going from plus to minus, so we're gone down 3 volts, and our total voltage is 0. So you see the potentials add as we go around the loop and back to our starting point. Just as we were on the mountain and we went from A to B to C and then back to A. So the key concepts that we covered in these lessons are: one, voltage is the energy either gain or lose per column of charge, and you can define that as the first derivative dQ of the voltage. Also, voltage measurements are relative, so you have to define the reference point. And finally, voltage potentials add as you travel from point to point. See you next video.